Hey everyone, and welcome. Today, we are going to pull back the curtain on the magic that's happening inside pretty much every device you own. We're going to unlock the fundamental language of computers, and it's built on an idea that is, way simpler than you might think. So let's get into it. Really, it all comes down to this one single question. Think about it. Every photo, every game, every text message, it all starts with what is essentially a simple switch that can only be on or off. So how do we get from that, from a basic light switch, to something that can power our entire digital world? Well, that's the puzzle we're going to piece together today. Okay, so to start, we have to understand the computer's most basic language. And you can forget the 26 letters we're all used to. As you're about to see, computers manage to do everything with just 2.
And here it is. It's called the binary system. This is the absolutely brilliant solution to that on or off problem. We just say off is a 0 and on is a 1. That's it. That is the entire alphabet a computer uses to build everything you see on screen. Every single piece of information, a song, a photo, this presentation, is really just a massive, massive string of these ones and zeros, or what we call bits.
So, you might be wondering, if a computer only has 2 symbols, how on earth can it handle something as basic as counting? Let's break down how it works.
It's actually perfectly logical when you see it laid out. So 0 is just 0. 1 is just 1. Easy enough, right? But there's no symbol for 2 in binary. So what happens? Well, we have to roll over to the next column, kind of like the odometer in an old car. So the number 2 becomes 1, 0. 3 is 1, 1. And then to get to 4, we run out of space again, so we roll over to 1, 0, 0. And you can just keep this pattern going to represent any number you can possibly imagine.
Now, as you can probably guess, when you start representing big numbers, you end up with these incredibly long, sprawling strings of ones and zeros. And that's totally fine for a computer, but for the humans who have to program them, it's a total nightmare.
And that's really the key thing to get here. Computers live and breathe binary, but people, we find it incredibly difficult to read. Could you imagine trying to find one little typo in a sea of a million ones and zeros? No way. So, to make life easier, programmers came up with a really clever shorthand. And that shorthand is called hexadecimal. Now, instead of 2 digits like binary or the 10 digits we use every day, hexadecimal uses 16 symbols. You've got the numbers 0 through 9, and then the letters A through F to represent the numbers 10 through 15. Its whole job is just to be a compact, much easier to read label for those long binary numbers. And this little chart here just lays it all out perfectly. Just take the number 10. In binary, that's a 4-digit number, 1010. But in hexadecimal, it's just the letter A. The number 15 is 1111 in binary, but just F in hex. See how that works? It's a clean translation that neatly bundles 4 binary digits into one single, simple character. So much cleaner.
And here's where it really clicks in the real world. That insane string of numbers on the left, that is the computer's code for the color pure red. It's basically impossible for us to read, right? But using hexadecimal, a web developer can get that exact same color by just typing #FF0000. It's the same information, just presented in a way that we humans can actually understand and work with. It's a game changer.
Okay, so we've seen how computers can count and represent data. But how do they think? How do they make decisions? Well, it turns out it all comes down to just a few incredibly simple rules.
Computers make decisions using something called logical operators. The best way to think about these is like the computer's tiny little rulebook. They are simple commands like and, or, and not that let the computer compare pieces of information and then give a result. This is, and I mean this, the absolute foundation of all computer logic.
So let's start with the AND operator. The rule here is simple, but it's really strict. For the final result to be true, or yes, both of the conditions have to be true. So, for example, should I go to the park? Well, is it sunny and have I finished my work? It's only if the answer to both of those is yes that I go. If even one of them is a no, then the final answer is no.
Now the OR operator, on the other hand, is a bit more forgiving. With OR, only one of the conditions needs to be true for the final result to be true. So, can I have a warm drink? Well, I can if the coffee is ready, or if the tea is ready. If either one of those is a yes, then yep, the answer is yes. The only way I can't have a warm drink is if both are a no.
All right, so we have our 2-letter alphabet, we have a way to count with it, and we have a simple rule book for making decisions. Now, let's connect all these dots. Let's bring it all together and see how it shows up in the digital world we all live in every single day. I mean, just think about your daily life online. The specific shade of color on this slide, that's defined by a hex code. When you type in your Wi-Fi password, the computer is using an AND operator to check if what you typed matches what it has stored. Saving any file to your computer is just the act of turning your data into a long, long string of binary. It is all happening, all the time, right underneath the surface. You know, this quote just perfectly captures the whole idea. Our entire digital world, it wasn't built on one single, massively complicated idea. No, not at all. It was built by taking these incredibly simple rules, like on-off, and/or, and just organizing them on a massive scale to create the elegant, complex systems we use every single day.
And that leaves us with a pretty big final thought. We've seen how just a few basic principles, a 2-letter alphabet and some simple logic, were enough to build our entire digital reality. So the question to really chew on is, what simple rules are being written right now that are going to build the foundation of our next reality? Thanks for digging into this with me.